Hey robot makers, hope you're having a good day so far. So do you want to learn how to install and run DeepSeek on a standard Raspberry Pi? None of this fancy GPU business for us today. We'll even look at running some other models, including Gwen, and let's see what we get up to in the show. We'll also write a Python program to interact with the model, and if that sounds good, then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get over to our slides. We've only got a couple to start with, and then we will get straight into it. Okay. And the reason for that is we might need some slides as a bit of cover, a bit of fill later on as we run some of these things. Well, let's get into it. So what is DeepSeek? You might have been hearing all about DeepSeek in the news in the past couple of days. DeepSeek is a new AI model, and it's really shaking up the AI industry. In fact, it's wiped out millions of, if not billions of dollars off OpenAI ChatGPT's owner's share price. So DeepSeek R1 is the release one of their open source reasoning model developed by DeepSeek, which is a Chinese AI company. And it's caused quite a stir in the AI world because it performs almost as good as OpenAI's 01 model or O1 model, but with the advantage of being open source and running on like a tenth of the hardware. In fact, allegedly, it only costs 5.6 million to train compared to the over hundreds of millions that it costs to train ChatGPT. Now, there are some controversy that it's actually been trained on ChatGPT, and that's why it's been so cheap. But we'll see how that plays out. What we do know is it's open source, unlike, ironically, OpenAI's ChatGPT, and this means that researchers and developers can have free access to it. They can modify it, they can deploy it, and they can investigate what it means to them, which is what we're going to do today on a Raspberry Pi, which is just insane. So how do we install this on the Raspberry Pi? So we're going to do this in kind of 4 steps. We're going to install Docker, which is the software that will allow us to run it in a container. I'll explain why we'll do that as we go along. Then we'll install Ollama, which is an open source large language model engine. It can run all different kinds of models. They call this a model zoo. We will then install inside Ollama DeepSeek, and that will allow us to actually start playing with that model. We'll also then, after that, write a Python program that lets us interact with that model, and it's quite a simple Python program that you can create at home too. So if that sounds cool, then let's get straight to it. So I'm going to show you now a bit of an example of what we can do with one of these models. I'm just going to load up on my screen here and then share with you directly, so you can kind of get a bit of a taste what this is all about. So I'm going to say hello to my audience. Now I'm running Gwen on this particular one because this is quite a fast model to actually run. So you'll be able to see just how quickly that responds back. So it said, "How can I assist you today?" So tell me a joke. And we'll see how quickly. This is all running on a Raspberry Pi, by the way. This isn't running on some kind of supercomputer with a graphics accelerator. Standard Raspberry Pi 5. So there you go. Sure, here's a classic one. Why was the math book sad? Because it had too many problems on it. Terrible. So we're going to learn how to get this interface up and running. This is actually called Ollama, and we can actually install all kinds of different models. I've got lots of different models on here that we can actually play with. So I've got something called Lava. Lava is an image recognizer. It can describe what it sees inside an image. It does take quite a while to do that on a Raspberry Pi, I'll be honest. We've got DeepSeek, we've got Gwen, which is what I've just been using, or Quen, is it? We have different versions of DeepSeek. We'll have a look what that means as well. And we've also got Dolphin, Phi, to name but a few that are on there. You can see we've got quite a few different ones. Mistral is also quite a common one too. Now we can actually have multiple models respond to a question at the same time, which is quite clever. So we could have, let's find a smallish one. Let's have another one which would be, let's try, just trying to think what would be quite quick to come back with an answer. Let's try this DeepSeek one here. So I've got DeepSeek and Gwen at the same time. So I'm going to say, tell me another joke. And you'll see how they have very different responses when they come back. They're going to actually run side by side. So you can see this as almost a bit of a speed comparison. So Gwen has immediately started providing another joke for us, and that's because that particular model is really small, it doesn't use very much memory, and therefore it can run really, really fast. So the size of the model can also define the speed of the responses, and it's because it doesn't have to go through quite so many tokens that it has to figure out an answer. You can see DeepSeek or Deep Thought, as I was going to call it then, is still thinking while Quen can come back with an answer. Now, because these are running at the same time on the same machine, you can see that it's basically maxing out its CPU. I can actually show you that in the background. If I go to, I think it's Dev 10, and you can see there, all 4 cores are running at 100% because they're trying to use every single ounce of CPU power to provide these answers for us. So you can see there, we've got the joke back now. Why did the maths book cross the road to get to the other side of the road, which was the other way round? I don't know why that's funny. You can ask it to explain the jokes as well, but I really wouldn't. Here we go. So DeepSeek is now coming back with an answer. I'm just going to move that out the way so we can see what that says there. So here's another joke for you. It came up with the same joke, interestingly, that Quen came up with before. So here's another joke. Why did the math book come to class? Because it had too many problems. Math pun intended. So it's a bit of a different take on that one. Maybe it told it better. Now, some models are more expert in producing and analysing code. So if you have a Python problem, there are different versions of this that you can actually run it through. So you see this Quen coder, we can use that one to pose questions. We can actually get that to write as a program. So if I go over here, let's get rid of that one. Let's change this model to the coder one. And then let's say, write a hello world program in Python. And let's see how accurately this comes back. So there we go. It looks pretty quick. So this is a basic program, print hello world. That looks like that would actually run. And there is even actually a run button. We can click there and we can see if indeed that will actually run. And it has done hello world. So this is all running again on a Raspberry Pi, which is just crazy. So let's learn how to do that. So the first thing I said on that slide, if I just go back to that slide for a second, was that we're going to set up Docker. So let's do that. Now I've got a Raspberry Pi that I haven't got Docker actually installed on yet. So let me just go over to this one, which is on, I think, number 7. Here we go. So if I type Docker, it doesn't understand what Docker is. It's never seen Docker before, kind of. So what we're going to do is we're going to clone a repository, which has got some files in it to make us fast track to install Docker. So Docker is a containerization engine. It allows us to create and download containers, which are images of applications that we want to be able to run, and we can do that in a really clean way because they're in a container. It's literally like a little box that's all self-contained. It has everything that's in there that's needed to run the application, and that application could be absolutely gigantic. It could be a really small Python program. There's all kinds of things that you can run in containers. So this show isn't about how to create containers. This is more about just how to use them to very quickly get up and running with Ollama. So the first thing I've done, if I just jump back a few folders there, I have on here let me see if you can see that. It looks a little bit small, so I'm just going to make the screen a little bit bigger so it says Shift Control and Plus. Let's see if we can get Shift Control and Plus. Let's get the size a bit bigger. There we go. I'm just going to move it over there because I have to, because I have OCD. There we go. Right, so hopefully you can see that with the contrast of the colours isn't amazingly great. So what I've done on here, I'm also running this just out of interest over 2 different internet connections. So there's the internet connection that you're watching me on. I'm streaming this from a Mac. I'm remotely connecting using Raspberry Pi's Connect to some Raspberry Pis that I've got over here. Well, they're connected to the Starlink internet connection that I've got. So sometimes it can be a little bit of a buffer, but in general, they should be able to download the models much, much faster and without interrupting this broadcast signal from here. So that's just a bit of housekeeping of what's going on there. So the first thing I'm going to do is I'm going to do git clone https www.github.com/Kevin McAleer /Kevin McAleer /clustered pi. So clustered pi is where I put all my files that I use to bring up Docker containers. So I've actually gone ahead and done that already. So if you press return on that, it'll probably take about 5 minutes to download the entire thing. It's about a gig and a bit in size. So if I go into clustered Pi, if I do ls, you'll see there's a bunch of folders. The folders are in blue there. The files are just in that sort of white color. So if I now go into the folder that's called stacks, stacks is how we can run more than one container at the same time. So if I do ls in here, you'll see there's a whole bunch of different things, and one of those that's in there is called Ollama. We've also got two other files, the green ones. The green ones are scripts. So this install Docker script is the first thing that we want to do. So we've grabbed our repository that's got all these different files in there, and we want to run this install Docker script. So the way that I'm going to do that is by doing // and then if I type in and press tab, it should, in theory, there we go, install Docker. It's just auto-completed that. If I hit return now, fingers crossed, it should grab Docker from the Docker repository and install everything that it needs, and all the little fiddly things that you need to switch on and off to get that to install. There's like little groups that need to be added to so that you can have quite a smooth experience with this. Sometimes you have to run this twice, and it's kind of idempotent. You can run this as many times as you like. There's today's word, idempotent. It means you can run it as many times as you like without actually changing, without it installing twice in effect. It just does the same thing. It makes sure that that's in place. So it just takes it a couple of seconds for that to install. Once that's installed, we can do docker space ps to see what is actually running in Docker, and it'll also check to see if we've got all the permissions that are correct. So you can see that it's grabbing all the files that it needs. It's getting the Docker Community Edition, that's what the Docker CE, and CLI is the command line interface. That's what we use to type in all our commands. If you're running this on Windows, other versions of Linux, not the Raspberry Pi OS version, which is based on Debian, I think you can actually get a Docker desktop install. That's what I use on the Mac. It's just a little bit easier. You can actually see things rather than having to type these commands. But these commands are really useful if you're wanting to get things done real quick. So, like I said, it's just taken a couple of seconds to install this. Once it's installed this, we can then get Ollama up and running. So I'm just going to hit OK on that. If I type in Docker, let's see what we get. It should bring up a load of commands that we can type in. If I do Docker ps, which is like list the processes, if we get this error, I think we just have to run that command again, and it shouldn't take that much longer this time to do that. I think also it says you have to log out and log back in to make the shell script things work properly. So what I'm going to do, you can just see there, it's been added to a group. We just need to close that window down and then start up a new one, I believe. So I'm also just going to do Shift and Command and plus to make it a bit bigger. If we now type Docker ps, there we go. That means that we've got nothing actually running in our Docker containers in the Docker engine on this machine. So if I now go into that clustered Pi, the stacks folder, and then the Ollama folder, this is where our Ollama files are hidden. So this docker compose.yaml file is all that we need to bring up both Ollama and then the Ollama web front end, which is called Open Web UI. So Open Web UI is what we use. It looks just like ChatGPT or Gemini or any of the other types of large language models. So if we just type in docker compose, make sure I'm in the right chat window there, docker compose up and then -d. -d means do this in a disconnected way, just bring up the containers, and you'll see there it's going to have to pull all the different dependencies that make up both of these two services. So there's the Ollama service that runs the model, and then the Open Web UI is the nice web interface that looks just like ChatGPT, the thing that we looked at the very start of the stream. Now it can take a little while for this to pull depending on what it's already got in its repositories and my internet speed as well. So what I'm going to do while it's doing that is I'm going to just check my notes and see what we're looking at next. See if there's anything else I need to talk about on there. So I think it does take a minute or two to actually install that. So while it's doing that, I'm just going to go back to my slides for a second. So yeah, we've installed Docker, we can tick that off. We're in the middle of installing Ollama, and then the next steps after that are looking at DeepSeek as a model that we can pull from Ollama. We can then interact with that model. So what I'm going to do, I'm just going to go back to that one there, you can see there that it's going to take a little while for that to pull. So I'm going to cheat now. I'm going to pretend that that's finished running, and that once it's finished pulling them, it'll actually start the service. So I'm running this on dev 07. I'm just going to switch over to dev 10, which has basically got the same thing installed. And if I just do the shift and control plus to make this window a little bit bigger, you can see there that I've done that Docker Compose up. It's pulled all the Ollama things and it's brought that service up. So if I actually clear the screen, type in docker ps, I can see that I have 2 Docker containers running. You might not be able to see that. It might look like the Matrix with all these very esoteric container IDs and image IDs and so on. But what I can see there is I've got 2 names. I've got Open Web UI, which is the web interface, and I've got Ollama. And I think the IP address of this machine is 192.168.1.126. There we go. 126. That's the IP address. And if we go back to the that list of I'll just type clear again. Sorry, clear docker ps. We can see that there is an IP address there which is 3000, a port. Sorry. So if we type the IP address colon and then that port, it'll actually load up the Open Web UI interface. So if I go back to my other web browser over here, let's actually type this in so you get the full experience. So 192.1.126, port 3000. It'll first of all ask you to sign in when you've never signed in before. So you can create an admin account. Make sure you don't forget your password on that. You can change your password, but it just makes it so much easier if you've actually got that all ready to go. I'm just going to check on that number 7, see if that's actually finished yet. If it has, we can see what that fresh install looks like. Otherwise, we can push on. We'll come back to that in a minute. Right, so let's go back to our web page, which is going to connect to that Open Web UI. So you can see here we have the top left over here. Sometimes when you first see it, it looks like this. So you can press this little button at the side to get that sort of history of chat sliding out. You've got some other things over here. You've got this little your initials, so whatever your first and last name are, you get your little initials there, and you've got the admin panel. So the admin panel shows you some things like the settings, for example, and connections is where we can pull some of the we can remove and add models if we wish from here. Now, where do we get the models from? How do we know what the models are called? So if we go over to www.ollama.com/models, this is where all the different models are, and they've even got some little things like show me the vision ones like lava, show me everything, which is all you can see there. Top of the list, updated just 11 days ago, is DeepSeek R1. And there are lots of different versions of this. Now this is how many billion tokens there are within that particular model. And a token, the simplest way to think of it is it's a single word. Now it could actually be part of a word, it could be 2 parts of 2 words. It can be more than just a word, but the simplest way to imagine it is just think of tokens as words, and you'll probably kind of get that idea right. So there's 1.5 billion words or tokens in this particular model, or we can have a larger one at 7 billion, 8 billion, 14 billion, all the way up to 671 billion. Now, you need quite a lot of RAM to run the larger models. So a quick way of thinking about this is the billions of tokens almost equate to how much RAM they use up. So 1.5B could use up 1.5 gig of RAM, for example. Might not be quite that, but it's a quick and ready way of thinking about that. So 7 and 8B will run on a Raspberry Pi 5 with 8 gigs of RAM. If you have the 16 gig RAM version, you could potentially run the 14 billion version as well. What you'll find though is the larger the model that you use, the more tokens it has to put into RAM, and the more that it's actually got to work through. So the CPU's got to be doing a lot of work to get the answers that you've typed in. So you can see there on all of these, we have different names of the models, and we have different model sizes. So we can use that combination of the model name and the size to actually download a model into Ollama. So you can see there, Phi 4, for example, that's 14 billion. Llama 3.2, we've got some other ones over here. Just looking at one that might be quickish to download to demonstrate this. So let's try that Phi 4, I think, was one that we've not got installed currently. So if I go back over to our regular chat window, if I just click on that, if I click on the drop down, if I start typing in the name of a model such as Phi 4, we've actually got that 14 billion version one downloaded. Let's try Phi 3. We've actually not got that one downloaded, so I can just hit there, pull from Ollama. They've got their own repository there. They call these repositories these collections of models, a model zoo. Just an unusual term that you get with that. So you can see there it's starting to download that, and this is downloading over that Starlink satellite. So it can be quick, it can be slow. I think it's up to 300 megabit connection if you're interested in that kind of thing. Right, so while that's doing that, let's have a look over at our Devo 7 and see if that's actually finished. So it's nearly done. It's finished downloading the Ollama, but it hasn't finished downloading the Open Web UI. I just wanted to show you what it looks like when you very first connect to it, because a little sign up thing. Okay, so let's get back to our slides just while that's doing that. So we've got Docker installed, we've installed Ollama, we've not pulled DeepSeek yet. That's the next thing that we need to do. And I think it'd be quite cool if I did that on that Devo 7, just to show you that process from scratch. And then the next thing we'll do is we'll write a really simple Python program to interact with that. And we can have another play with typing some fun things in and see how they compare as well. So I'm hoping you get the idea that this is actually really easy to do, and you can use some really cutting edge technology on a standard Raspberry Pi. This is a really low energy computer, and you know, compared to like a desktop computer, like a Mac M4, Mac Mini or whatever, Raspberry Pis are quite underpowered compared to them. So the fact that they can run these models as quickly as you've seen at the very beginning of the show there, that shows you just how powerful these things are. Right, so I'm just going to move that out of the way there so I can see what I need to see there. Let's see. Yep, that's good. Right, so let's get back to Devo 7, see how we're getting on with that. That's very nearly done, so it's 1.3. So it's finished pulling them all. It's now kind of unpacking them and getting them ready to run. So it usually takes about another minute to do that. So while that's happening, let's go back over to our Dev 10. Let's just put that on that htop. Htop is a really good command for looking at what the top things that are running on your machine are. So you can see you've got these 0, 1, 2, and 3. These are the different cores in your processor. You've got how much memory that's being used. So this is a 16 gig Raspberry Pi 5, but we're only using 1.35 gig at the moment, and the swap file, we shouldn't really be using too much of that because they don't perform particularly well. And the other thing we can do, if I press F6 on here, we can actually sort by what's using the most memory. So you can see there it's this Python program, and that's essentially the Ollama web UI interface. If I do F6, we can look at, do that again, we can then sort by CPU, and that will show us what's using the actual most CPU at the moment. So not a lot is going on there currently. So if we now head back over to our Open Web UI interface, which is connected to that Dev 10, we can start typing some things in. So all I needed to do to get DeepSeek was type in DeepSeek DeepSeek R1, which is the name of the model, and then colon, and then the model size. So if we wanted the 1.5 billion version, which is the one I would recommend you start on because it's the smallest DeepSeek model that there is, if you press return on there, it will either download it, or if you've already downloaded it in Ollama, it will make it so that's now the default one that you can use. So you can say, tell me a fun fact about the Roman Empire. We can hit return, and it'll start chugging its way through that. So it always does this thinking stage, unlike some of the other models which immediately start sprawling out text. It's interesting that it has much more advanced reasoning skills, and it explains its thinking once it's done this initial kind of pass through. So again, you have to just remember and set your expectations. It's running on a Raspberry Pi. It's not like running on a NVIDIA graphics processor, which can do a lot of math very, very quickly. But it's insane the amount of stuff that you can get from this once it returns its result. And I can just see now, if we flick over to here, this is the CPU usage on that Dev 10 machine, which we're actually running that request on. And you can see there that it's the CPU is running pretty much at 100% there as it's crunching its way through to try and provide that answer for us. So if I head back over here, there we go. So it says the Roman Empire's impressive architecture includes iconic Colosseum and what's that, Collimaden, never heard of that, which remains marvels of the history. Their efficient military strategy utilised mobility during sieges, showcasing their effectiveness. Additionally, the empire was divided into administrative provinces, fostering resource management efficiency. So there you go. And it's the other thing that it's still doing, if we look over here, is it's still maxing out even though we have the answer. And that's because it's now summarising its response, and it's going to create a title for our chat. And it's going to save that title in this little chat thing once it's done that summarizing. So it has to kind of do two jobs before it's finished using all that CPU usage. So while it's doing that, let's have a quick check back on, there we go, Devo 7. That looks like it's nearly ready to start the process for us. And if we go over here, you can see there it's summarized and it says, okay, I think I'm trying to, can we make that any larger? Just want to see what it actually says it's called there. It's not clear what actually it thinks that particular chat is called there, but you can see it's come up with a short name for that. Okay, so what we will do next then, I was hoping that Devo 7 is going to come up so that we can actually see it. So what I will do, I'm just going to try and jump the gun on that one. So what we'll have to do on that one is probably using quite a lot of CPU in itself just to install this and unpack it. That's why it's been a little bit sluggish. It could also just be that Starlink is also being a bit sluggish because there's a lot of models being pulled here, there and everywhere. Once it's done that, I'm going to start a browser on this actual machine and see if we can actually connect to that browser and to the Ollama that we've just installed. So we'll do that by hitting this little blue globe icon over here, which should fire up Chrome. We've got plenty of RAM on this machine, I think it's the 8 gig version, so that shouldn't be any problem. And if we go over to 0.0.0.0 colon port 3000, not 30,000, 3000, that is the port that we have OpenWebUI installed on. You can see that it's beginning to respond back now, and we can see that it's brought up the Ollama thing and it's just starting the OpenWebUI, so it's not quite there yet, so it's very nearly there. And if we give that another refresh, maybe it'll come up with the full page that we're after. I can see it's got the fav icon, so it must be very, very nearly there. And then we can get to the signing up part. I just wanted to show you that just for completeness. But because this is a live stream, I don't want to keep you hanging around waiting for that to come back. So while that's doing that, let's get over to Visual Studio and start writing some Python code that we can actually use to contact Ollama and a particular model that we want to use and get an answer back. So that's the next thing. So Johnny's correcting me there. This isn't Chrome, this is Chromium, which is the open source version of Chrome. Thanks for that, Johnny. Right, so I'm just going to go to me for a second. I'm going to make sure we're in the right code. I'm just going to load up a nice blank livestream.py. And I'm going to now go over to here. Right, so we also need to just zoom in a bit on here so that you can actually see what I'm doing. So let me just find where that is. It's under Window. So I should have got this all set up ready to go for you. Appearance. There we go, zoom in. So it's Command and equals. I do that. I just minimize that for a minute. Let's clear that console and let's type in some code. So I'm just going to get my code up on another screen, and this is the code that is in a repository that I shall share the link to in a second. So if I go to github.com youtube.com/Kevin McAleer/ and I think it's Ollama-Python. Then that should give me the code right. So let's get this up and running. It's literally 30 lines of code, so it's really, really quick. So the first thing we need to do is import requests. Now, if when you run this, it says cannot find requests, you simply just need to do a pip install requests like that, and it'll make sure you've got that installed. I've already got that installed, so we're good to go on there. Right, we need an Ollama URL, so let's call that Ollama URL, and the IP address of the machine that I've got this running on, that dev10, is 192.168.1.126, colon, and the port, which is 11434, and then /API/generate, just like it's trying to help me with there. And that is, let's put a little comment there, that's the Ollama server URL. So we can change that. We can actually have multiple ones running, and we can pick from maybe 4. If you've got a cluster, you could pick from them. Right, well, next we need a model. So let's say model equals, and let's give this DeepSeek. And again, so it's DeepSeek R1 colon, and then the size of the model 1.5B, which is the size of that particular model that we want to use. Let's give that a nice little comment. And we can choose whichever models we've already downloaded. If we haven't downloaded them, it'll return an error. We can try that out in a minute. Right, we now need a little function, which is send request. So it's helped me type out that piece there. So let me just read this through. So send a text prompt to our Ollama server and return the response. And the first thing we need to do is create a little Java, a JSON string. So this is, it looks like it's a Python dictionary, so we've got some key value pairs, but this is also just happens to be some JSON that we can send. So data equals, and then we've got this open squiggly bracket, model equals model, so that's DeepSeek R1 1.5 billion. We've got the prompt, which we're going to pass in to this function, which is what we're going to type in, and then literally type in, and then we can say stream is true or false. We're actually going to set that to false to begin with. And that's whether we want each word to sort of come back as it thinks of it, or whether we just want the full thing once it's finished. So it gets a bit more complicated and fiddly if you say true on there. So for the simplicity on this one, we're simply just going to make it false. So then response is what we want to receive from our Ollama model. So response equals requests.post. So this is what we're going to send to the Ollama server. That we're going to send it to that Ollama URL we defined above. I'm just going to take that stream equals true off there at the end, and the JSON, which is what we need to send it, is data, which we've just defined just there. And then we response.raise, do we need that one in there? Let me just, yes, raise for status, so raise any errors for bad responses, and then for all good we can say return response.json. Sorry, these little pop-up things don't always help, and we want the response to be returned there. And if there's been any errors, so this try except is just a way of catching errors. So accept request.exceptions.request exception as E, and then we can just return what that error is there. Right, next we need a little if name equals main, and we just need a little piece there that says user input equals input, enter your prompt. We can then capture that user input and send it to the send request. So response equals send request user input. Response will be the actual response back from the model, because it'll go through the little routine we just created, and we can then say print. So /n just means on a new line, Ollama response, and then we can print out the response itself. So let's give this a go, shall we? If we press the run button, we should now run this code. So down here in the console you can say enter a prompt. So let's do the tell me a joke. Let's see if it gives us that exact same joke again about the maths class, which it seems to be its go-to one. And if you remember last time, it took a little while. No, it's come up with a different one. So sure, here's a light-hearted one for you. Why don't skeletons fight each other? Because they don't have the guts. And it's even put a little emoji in there. Not bad joke. and it was pretty quick. How quick was that? That was probably about as quick as if you were running this on ChatGPT, Ollama, or DeepSeek itself on the web. But we're running this on a Raspberry Pi locally. We're not sending any data out to anyone. This is entirely within our ecosystem. So I really think this is it's just crazy that we can actually do this. And look at that, we've got 28 lines of code to write that. Now we can make this even better. So if we want to make this even better, let's go up there. We're going to change the model this time. Let's make this run on that Quen, and that should be okay. But we're going to add to this now. So we're going to say we want to define a persona. So this is what we want the personality of our response to take on. So we can say you're a knowledgeable teacher. You could have anything you want in here, like, you know, you're a sassy, I don't know, sassy American. You could have whatever you want in there. I don't know where that came to. And then we can say what the context is. So explain it like I'm 5. I always think of Michael Scott when they're trying to explain what a surplus is in The Office. So the persona plus the context will give the prompt a bit of extra stuff to go through. And all we need to do there is, where we have the prompt, we can simply just say persona plus context plus prompt. And the reason these are capital, just out of interest, is because these are constants. These don't change during the run of our program, whereas things that are in lowercase, like the prompt, they're variables, they do change during the life of our program. So that's just a little by the way there. So let's run this one. We're now using that Quen. So let's try tell me why the sky is blue. That's quite a complicated thing. Let's see what it comes back with. And what we can also do, if we wanted to, we could flick back to see on that dev 10. I can see on that dev 7 that's now up and running. Dev 10 is, you can see, flat out trying to come up with our answer to that. We go back to over here, we can see it's not quite come back with an answer yet. Now I do find this interesting. The more complicated prompt you provide, the more it actually has to think about the answer, because not only is it saying why is the sky blue, it's saying explain it like I'm 5, and you're also a knowledgeable teacher. So it has to take on that persona. So let's see what it's come back with. It's come back with quite a big answer there. So it says the sky appears blue because of something called Rayleigh scattering. When the light hits objects such as air molecules, this doesn't sound like explain it like I'm 5, but hey, some of the energy of the light is scattered away from all directions. However, since air molecules are much smaller than a typical wavelength of visible light, between 400 and 700 nanometers, they scatter the shorter wavelengths more strongly than the longer wavelengths. Since blue light has a shorter wavelength than red light, which has the longest wavelengths, it scatters more strongly by air molecules. So there we go. So we're writing very, very small amounts of Python. We're sending off a request. We can enhance that by making it have a context and a persona, and it's then giving us that response back. And we can even decide what kind of model we want to run this on. So we could keep, let's go back to our code up there. Let's change that model. So there is one which is the code one. Let me find that one. I think, was it Quen-code? I'm not sure if it's that. Why is it messing up my text? I'm just going to check which model that actually is, because I think I just want to make sure I get that right. So which one is the code one? So let's go for tools and coder. So Quen 2.5 dash coder. So let's do Quen 2.5 dash coder, was it? Coder, yes. Right, we can also make sure these are blank for this particular one, because we want it to write some code for us. So let's run this one. And the prompt that we're going to enter this time is write a Python program to add two numbers together from a user. Let's see what it comes up with, and it's given an error there because we don't have that model installed. So let me go back to dev 10 through our interface and see if we've got the coder one. So Quen 2.5 coder, maybe I have to type in the whole name there. So colon 0.5b. Let's try that. So let's go back to our code. Let's change that model. So colon 1.5b. There we go. Let's try that again. And let's type in that same thing again. I'm just going to copy and paste that. Nope, it's not happy with that. There's something wrong with that. Qwen 2.5 coder. Qwen 2.5-coder. Can't see what I'm doing wrong there, so I'm just going to look and see what we have going on there. Let's try it just with Qwen and see if that's any better. Let's try that. Oops, I typed in the wrong thing there. Paste over there. There we go. So that's working this time. But this one isn't running on a code specific one, but let's see how it performs. It's quite a small model, and therefore it might not make very good code. This is what I'm interested to see. And we can also try this on DeepSeek as well. 0.5, that's what Johnny's just spotted there. So if I just change that to 2.5 coder, or spotted 0.5b. Just make sure that's right. Yes, well spotted, Johnny. So I'm going to let that one finish. So this should be a Python program. Let's see if this looks right. Well spotted. This is what I love about live streams. You can interact and people can help you debug code. So here we go. Sure, here's a Python program that adds two numbers together from the user. So ask the user for input. Number 1 equals a float input, enter the first number. That's pretty good. And then secondly, number 2, float input, enter the second number. Add the two numbers together, result equals number 1 plus number 2. And then print the sum of. So that looks pretty good. If we actually ran that in the Ollama Open Web UI, we could actually run that code directly and see that it actually works properly. So I've now updated that with that coder, and maybe let's try that in C or Arduino instead. Let's do that instead of Python. So let's run that again. I'm going to paste that in instead of it being a Python program. Whoops. That's a bit of a problem there, isn't it? I pressed the wrong button and it's messed up. I'm just going to cancel that and restart that. Let's type that in. So write an Arduino program to add two numbers together from a user. Let's see if it's any quicker or any better or any different response. I'm just interested to know what this particular model can do, and then we'll try that in DeepSeek as well. And this is the only thing about running it on a Raspberry Pi. It is a little bit slow depending on the size of the model. If you run this on one of the 14 billion token models, it can take like 14, 15 minutes to come back with a response, which isn't great. So here we go. It's come up with all kinds of stuff. So there you go. Certainly here's the Arduino code snippet. And it's showing you this is Markdown, saying that this is a C++ code, interestingly. So void setup, which is right, serial.begin. Int num1 and num2, that's right. Serial print, enter the first number. Scanf, and then reads in that first number as a, is that decimal or just a number? And then reads in the second one, and then it says int sum num1 plus num2, and then print out the result. That looks like that works, and what I like about this version, the code version, it explains the code. So this is how it's different than that running that regular Qwen. And remember, this is a 0.5 billion model. It's 500 million token model. It's quite small, yet it can actually explain the code. So that's pretty impressive. Quite impressed how well that one came out. So what I'll do now, I'm just going to flick back to our slides for a second, because we've now achieved installing Ollama and DeepSeek on our Raspberry Pi, and we've even written a few Python programs. Let's have a look. So yes, that was they were the slides I had ready to install Docker and to install Ollama and to install DeepSeek, and then finally to write the Python program. So we've done those steps. And I did have some other slides to hand, just in case I needed a little bit of filler. I'll just quickly go over these. So how does DeepSeek R1 compare to the other open source, or the other models that are out there, maybe not open source? So if we look at the AIM 2024, so this is, I think it's like an American maths challenge where you get so many questions to answer. And you can see there DeepSeek 1 is actually winning there, so the accuracy percentile is actually higher than the OpenAI, which is the ChatGPT one. The smaller size one, so the 32 billion size model, only scores slightly less accurately. And then we've got the OpenAI 01 mini, which is their very fast one. You can see that's significantly less performant. And then finally we've got DeepSeek version 3, which is down here. Code Forces, that's another AI challenge, as is the Google. What does that stand for? I've written this down so that I could tell you what that is. So the AIM is the American Invitational Maths Examination. Code Forces is an online platform for competitive programming, and they host various different code challenges. GPQA Diamond is the Google Physical AI Quadrant. It's a specialized group of AI researchers at Google's Quantum Artificial Intelligence Research Lab. The diamond signifies a highly skilled and accomplished team within the GPQA, apparently. Maths 500 is an advanced mathematics course offered by University of California. So there's some challenges within that. And then the Master of Management with Learning and Ultimate. I'm not sure that's legit. I think I actually got an AI to tell me what they were. And then we have the SW Bench is the Software Engineering Workbench benchmark. And that's a suite of tools designed to evaluate performance of AI frameworks. So you can see there, in general, the red one, the R1, is pretty much outperforming, other than the Code Forces one where the OpenAI. But you've got to remember, this one cost 56 million to train compared to the hundreds of millions, if not billions, that ChatGPT took to train. So it's pretty much performant on all of those different tests, and we can run that locally. We can get that actual model and run it locally. That's amazing. So let's have a look at that again. When you're installing Ollama, don't go for the apt install Docker, because it's actually quite an old version that you get through that route, and it doesn't have all those little nuances that mean that you can just type the commands in, like docker compose, docker whatever. If you go that route, you have to run it as like sudo. You have to have a super user, and I found that it doesn't play nicely with some of the scripts I've written. So if you follow the code that I've just shown you now, it'll work fine. So prompt engineering, I actually got these from Raspberry Pi's own course that they have on using large language models. I'll share a link to that in a second. But they have some best practices. They call this Ocean, which is easy to remember. So we have objectives. Give it a persona. Behave like an expert in teaching. Behave like a sassy American. Give it some context. So how do you want to make this behave? So explain it like I'm 5. Who encourages people to understand? So that could be part of the objectives and the persona. And then give it examples. So you can say, for example, so say you're giving you want it to generate some code, you can actually paste in the code that you've already created as an example, and that tells the model the kind of output that you're looking for. I use this to do some of my course material when I'm creating some of my courses online. I can paste in a format and have it put some blurb on some of the slides where I can't be bothered typing this sort of introduction, for example. It can just take that format and produce something very, very similar. And then on the assess, you can see there, check the responses that you want it to have. So this is the usual cycle. You type something in, it's not quite got it right. You then negotiate, you kind of clarify the question, be specific as possible to get the actual output you need. So that assess and negotiate, quite iterative on there. But yeah, I thought Ocean, that's quite a nice thing to take away from that course. And AI on the Pi. So smaller models run faster. So 0.5B to 2B models generally are small and run quite performant. 4 to 7 billion are large on the Raspberry Pi. If you've got a desktop computer or a server that's got, hundreds of gigs of RAM, terabytes of RAM, whatever, you can run the much larger ones. And if you've got graphics cards, these NVIDIA graphics cards to accelerate some of that stuff, then you can do that too. Now, unfortunately, the Raspberry Pi AI hat and the AI kit, they can't accelerate large language models. You actually have to upload the model into the AI accelerator for them to work well. So you need a lot of RAM on there. And the ones on the kit and the hat, I think they only have like 8 I'm going to say like 8 gig of RAM, something like that. It might be 8 meg of RAM. They don't have very much basically, so they're better for doing image processing rather than large language models. But I'm sure that will change. That'll be my prediction. I don't have any inside knowledge, but I'm sure that there'll be a hat that helps with large language models. It's a problem that's wanting to be solved. So remember that Raspberry Pi is a low power computer, so set your expectations accordingly. The results are amazing that come out, but you might just have to wait a little bit longer than, say, a desktop computer. And the larger models always give better answers, but can take longer to provide that, so just bear that in mind. If you can go away and get a coffee and come back, you might end up with a really, really good quality answer. So here's the model zoo I've just gathered from. This is from the Ollama website. So Llama 2, that's actually by creators of Facebook and Instagram, Meta. So they developed that as a kind of general purpose all-rounder, and it comes from 7B up to 70B in token sizes. Then we've got Mistral, which is known for its efficiency and good performance, 7 billion tokens. We've got Code Llama, which is a specialist one for doing programming and code generation, code analysis. So maybe we could try that one in a minute. Phi 3 and Phi 4, they're some Microsoft generated ones. Then we've got Gemma, which is the Google DeepMind. So when you use Gemini, you're using part of this Gemma. You tend to get like the second or third generation, not like the one that they've got as the current one, is my understanding. But they've got 2 billion, 7 billion token models, which is pretty performant. Then we've got Qwen 2, which we've just been looking at. So 0.5 billion up to 72 billion. And that's been developed by Alibaba, who have the AliExpress web shop where you can buy things very, very cheap in China. Then we have Lava. Lava is really, really cool. If I can get that one to work, I'll give that a try in a second. So Lava, you can have a model interpret what is in an image and describe in detail what it can see in that image. So it combines a visual encoder with a large language model. They've got Tiny Llama, so 1.1 billion tokens, another general purpose one, good for resource-constrained environments such as the Raspberry Pi. You've got Star Coder 2, which is a specialized code generation one, and then of course we now have DeepSeek, which has got 1.5 billion all the way up to 671 billion tokens, which is just crazy. So if you go onto like the DeepSeek website, the 671 billion model is probably the one that you're using, whereas we're using the 1.5 billion, so it's a much more smaller, doesn't know as much stuff, maybe not quite as good at reasoning out stuff, but it's still very, very impressive. I would say it's the reason this video is the stuff that you can get out there. So it's the first generation of reasoning model with comparable performance to OpenAI's O1 model. So there's our model zoo. And if you want some extra resources, then you can definitely check out that Raspberry Pi course. That's where I got that Ocean thing from. So projects.raspberrypi.org/en/projects/AI-LLM-prompt. And it tells you all about prompt engineering and so on. And you can also check out kesrobots.com. We've got all kinds of free courses and stuff over there as well. You can learn how to do this. You can see the write-up. If you want the instructions on this, just head over to kesrobots.com and you'll find the link on there. And if you want to know more about those models, head over to the Ollama Model Zoo and you can see what different types of model. They're always updating it. There's always new stuff on there. So if you like what I do and you want me to make more of these kinds of videos, please drop me a like. Let me know what you think about this. Drop me a comment, let me know what your preferred AI is. So do you use ChatGPT, Gemini, Copilot on the Microsoft environment? If you're on Notion, do you use Notion AI? What else is there? What else do I pay for that has AI in it? I think they're all the ones. Let me know what you use anyway, if there's any that I haven't mentioned. DeepSeek, for example. And if you've not subscribed to the channel, please subscribe. It really means so much to me, and it helps the channel grow. Okay, so yes, I do also go live every single Sunday. So if you want to drop into the live stream chat, you can do. You can help me debug some of the code as well. So what I will do, just before we get on to the last couple of slides, I want to have another try of something. Let's see if we can get that model, the image recognition stuff working. So I have an image on here. I've got a little image of my little chihuahuas. They're getting ready for their bed with their little dressing gowns on. So that's image.jpg. I think it's like 300 kilobytes. It's like a tiny little image. But if we go back to our live stream code, let's see. Well, actually, I've got this lava one here, which I've done. It's got the same code that we've seen before. It's just using the lava model. I've got rid of the persona and the context, and it's just we have an image file one in there as well. So what we have to do with the image file is just encode and upload that as part of that stuff that we send up there. So if image path with image path RB, I'll tell you what, rather than do it in the code, I'm going to try doing it in the interface, because I don't think this bit actually worked when I tried it last time. So I'm going to go back to our interface. I'm going to choose a new chat. I'm going to do the lava, and I'm going to add a upload file, which is that image. Where's it gone? Is it in the downloads? No, it's in the code, which is in fact, that one there's 35k. That'll do. Let's grab that one. Tell me what is in this image. So again, this is running on the Raspberry Pi. Let's hit send. That's another AI that I use that is popping up on screen that you can't quite see, and it's the Grammarly. Right, there we go. So tell me what's in this image. And I found that this one does take quite a bit of processing power on larger images, because there's obviously more data for it to crunch through. I'm not sure how these actually work. This is something that I would like to know more about. I was wondering whether it's a bit like image detection, where it can detect objects with an image, like it can recognize these as dogs. But it's so precise, it will say like there's 2 dogs with large ears wearing, bathrobe, sat on a blanket on a floor, something like that. So I think I've actually got this one already answered over here, for example. So this is what Lava came up with this morning when I was looking at this. So it says, in this image there are 2 dogs sit next to each other. Both dogs are wearing clothing. One is wearing a pink jacket or blanket. The other is dressed in blue with a bow tie. So I think it thinks these little bauble things are a bow tie, which is interesting. They appear to be well groomed, thank you, are looking towards the camera, which they both are. The background suggests an indoor setting with a blanket on the floor. That's actually on a couch, but I'll let it have that one. The image also contains a watermark, which it doesn't, interestingly, which seems to be a digital signature or logo at the bottom right. It's not clear what the specific is associated with that watermark, so I'm not sure what it's getting confused with there, but that's quite interesting that it should say that. So we can leave that and it probably produce the same kind of answer. Be interesting if it doesn't. There's always a bit of randomness in each time you run these things. It doesn't always give back precisely the same answer. Now what you can also do in here, if I go back to this one here, for example, you get some stats. So if I hover a little eye there, you can see how many tokens per second this came back with. So the prompt token per second was 0.96. The response tokens was 1.32, which is pretty quick. So overall, that one took 11 minutes. That one took 11 minutes to actually come up with the answer. So we might be waiting for some time if we were to wait on that one. That's why I wanted to leave that to the end. And if we look at some of these other ones, let's look on there. That took 53 seconds to run, and it did 7.59 tokens per second for the response and 12.18 tokens per second for the prompt. You can have a look at some of these other ones. This was a Quen coder, which I asked before to give me write a hello world program in Python, and this is what it came up with. You can see there 20 tokens per second pretty much, with 48 tokens per second for the prompt token. So pretty quick, and it took 8 seconds to come up with that piece of code. So this is why I started with Quen. It's so quick. So Quen I think is probably my go-to for Raspberry Pi based stuff. It's a really small model, but it's pretty accurate, and it's pretty performant as well. So yes, it's probably going to take it some time to do that. So if we've got time at the end of the show, I'll come back to that one. That's why I wanted to cover that off there. Cool. So if you haven't noticed already, we have a new store for some of our products. I'm just grabbing them out my desk there. So I've got the Robot Maker's Almanac. So you can grab one of these now on the store. I was hoping to get these out like this time last year, but it took an entire year to get that store open. So the store is now open for business. You can grab one of these. They're essential for any robot maker. All the information that you would need to have, you've got to hand. There's all the pinouts, for example, for the Pico. We've got pinouts for the microbit, which I've just got on my desk there. We've got pinouts for the Arduino. We've even got pinouts for the M5 stamp and M5 stack core. We've got those as well. As well as the Raspberry Pi. You can see there we've got the, can't quite see because the brightness there, but it has the Raspberry Pi A, B and 0 all kind of overlaid on there as well. Then we have all the dimensions. So if you want to know what the dimensions of the Raspberry Pi are, they're all in there, and that's the 0, the Raspberry Pi 5, the Pico, the Arduinos, the M5 stacks, the camera modules, the servos, it's all in there. So an absolute steal to get that one. And if you want your own little Maker Notes book, you can also grab one of these little notebooks and you can jot down your own ideas in there as well. And you can get these in packs of 3 in different colours. We also have the PCBs. So where did I put that? I had this to hand a minute ago and now I've lost it. That's the remote control. I don't know where I put that. I had it a moment ago. It's probably dropped on the floor somewhere, knowing me. This is the remote control, the gamepad that we covered last week. You can get yourselves one of them, get multiple of them if you like. There's also the Pico Tamachibi and also the servo helper. We'll probably do a show on the servo helper as well at some point, just so you can see that. Jeff says he built one of the gamepad 2s. He's ordered one. Great. The only issue was the soldering the OLED display, but he got it in the end. Yeah, it's a bit of a tight fit there. Maybe if I do a version 3 of that, I might move that one somewhere else, but it's a really fun gamepad to produce. And last week in last week's show I showed you how to connect that with Bluetooth to a robot, and it connects instantly. It's so satisfying, and if you were to turn that robot off or it went out of range, it reconnects again instantly too. So very, very robust, and it can run off a battery as well. So definitely check those out, kevrobots.com. You'll find all the links on there as well. And what else we got on here? We have, yes, our Discord server. If you've not checked out our Discord server, head over to kevrobots.com/discord and you'll get a sign up link there, and then you can grow our very growing, very vibrant community of people, and you can share pictures of your robots, projects that you're working on, pose questions and get those answered. So you're not just emailing me directly, as some people still tend to do. I just don't have time to respond to all of those, I'm afraid. I do read every single one though, but can't always respond. And if you want to follow me on social media, you can do that by going to KevMcAleer at threads.net. I'm on Threads. I'm on TikTok at KevMcAleer6. TikTok's back. Woo! I'm on Instagram at KevMcAleer. I'm on X at KevsMac. I'm on Mastodon at KevsMac at mastodon.social. And I'm also on Blue Sky at kevsmac.bsky.social as well. And you'll get all kinds of behind the scenes things, such as is that that's switched off. I got these little robot arms. You can just about see that there. This little robot arm here. I got sent 2 robot arms by Waveshare. I'm going to be doing a video about these very shortly. These are absolutely amazing. They've got a little Raspberry Pi camera holder there, and somewhere for a Raspberry Pi, I've got a Raspberry Pi 0 connected to this arm. And yeah, this arm tries to take me out whenever I try and start it up. I've got it bolted to the desk. If I go over here, you can probably just about make out. In fact, I'll do that one there. You can just about make out. If I make this go to a funny angle over here, and I switch this on at the base, it'll go to its sort of default position. I've been learning how to program this, but yeah, you can basically program it in Python. If I leave it on for any length of time, it sort of swings around and sort of tries to take me out, which is just crazy. Anyway, let's get back to our slides, because we want to thank everybody who's actually joined already. So if you want to join, you can do that in a number of different ways. You can make sure I've got over there, I can see. We have super thanks. So if you're watching this on replay, you can do a super thanks. If you're watching this live, you can do a super chat where you get your name brought up on the screen. You can join the YouTube membership program. It's at the bottom when you've subscribed. That gets replaced with a subscribe plus button now, I believe. And if you press that, you can join the YouTube membership program. Or you can go to the Buy Me a Coffee and buy a coffee, either as a single one-off coffee or as a regular thing if you want to do that every single month. So you can do that by going to kevsrobots.com/coffee. And let's give a shout out to our supporter, shall we? So if we look over here on the left-hand side, I had Tom GNU buy a pack of Top Trump cards. These are all the different microcontrollers. And I have little Top Trump cards. Does anybody know what Top Trumps are? It's like a game that you play, it's a bit like Uno or Snap or something. There's a card game, but you basically say what's the processing power of the card that you've got, and whoever's got the highest one wins that card. That's top trumps. Nothing to do with the president. We have V Wilcox, who bought me a coffee. Thank you for that. Cody Marie bought me a coffee. Thank you for that. And Doug bought 3 coffees. Thank you, thank you, thank you. And membership wise on the Buy Me a Coffee side, so Marie, TKD, Andrew, Shemi, Jeff, Corti, Marling and Tom. Thank you all for your continued membership of that. And on the YouTube side, we have Marie Mayer, we've got Michael, Steve, we have Ford, Bello, Oxrad39, Littleback, Paul, Johnny, Prem Kumar, we have Steve, John Paul, we've got Alistair, we've got Cassie, we've got Tinkering Rocks, Johnny Bates, and we have, of course, Tom. Thank you so much for subscribing. I can't say how much it means that you continue to support my work. It means so much to me that you do that. And if I go over here to my last slide, we've got the little spinny logo which tells me it's at this point in the video. If you're watching this on replay, then over here YouTube will recommend a video from my over 400 videos archive. Hopefully one of those will pique your interest. If you watch one of those after watching this one, it also helps the channel growth as well, because YouTube realizes that my content is really awesome and people want to watch it. So by watching one of these, you're also helping grow the channel. So it's at this point in the video, I'll say thank you so much for watching, and I shall see you next time.